So, hello everyone. So, thank you for the introduction. So, first of all, I do quite a lot of machine learning and data science, and my language of choice is F#. So, who here has ever seen an F# code? Oh, a couple of people, nice. And how many of you are .NET programmers? Yeah, quite, well, more F# than .NET, that's very nice. So, and how many of you are doing data science or machine learning? Okay, so this will be sort of talk to get you excited about data science and machine learning. So I'll be using a data set from StackOverflow, because that's sort of a data set that we can all probably relate to. And I'll be showing you some cool things that we can do with it, and hopefully you will see some F# on the way. And then Thomas, I think we will be talking a bit more about the F# side of things. So let's start. So first, a little disclaimer. I'll be talking about Stack Overflow, but I am in no way related to Stack Overflow. I just got the data from Stack Overflow. I'm actually related to University of Cambridge, so I hope I won't make it ashamed. And Cambridge is a very nice place. It looks like this, if you ever want to go there. But then, yeah, this is the Cambridge on a nice summer evening, but then I work here, so let's in bioinformatics, and I'm doing machine learning in bioinformatics and helping biologists analyze their data. And we are working on the level of genes, and we are investigating cancer. So that's quite a complex area, and my normal data sets that I work with look like this. You probably can't understand that. I can't understand it either. So bioinformatics, it's very nice. It's a very nice area because you can help research in cancer and things like that, but it's incredibly complex if you don't have any background in biology. So in my free time, I like to play with other data sets than just my work data sets, because these are incredibly complex. And if I get some results from my work data sets, then I basically don't know what they mean unless I go to some biologist and show them the results, and they will say, oh yeah, that makes sense. I can't see that myself. So, for example, I played with Star Wars dataset, where I extracted social network from Star Wars movies. It's quite a lot of fun. And yeah, I think I have some slides here. It even got published in a French magazine. It's like a French edition of Scientific American, which I was very excited about. But then I look at the actual article, and they are saying that I am from Oxford. So that's basically the most thing that I made that most people will see. But they say that I'm from Oxford, so I'm not talking to them anymore. Back to Stack Overflow. So why Stack Overflow? Well, we all use Stack Overflow all the time. Maybe not all of us would copy and paste everything directly from Stack Overflow, but yeah, I think all of us do that sometimes. So, Stack Overflow. What can you do with Stack Overflow? Well, they have quite a nice API that you can use to download data, but it's sort of more for integrating it into some kind of service. I don't know if you want to get a notification every time your favorite tag comes up, then you can use this API. Or if you want to integrate it into your own website. And about a month ago, or actually almost 2 months ago, they also integrated Stack Overflow into Google BigQuery. So now you can use SQL to just query the database and get some results from that. But I did this analysis before, and also SQL is not that exciting as F#. So you can actually download the entire data dump of Stack Overflow and have it locally on your machine, which I think is pretty exciting. And they publish it every 3 months. So every 3 months you can download all the data they have on Stack Overflow, on answers, questions, history of all the posts and all the comments, etc. And if you are interested how big is that, well, this is actually just from my command line where I printed it out. And it's a lot of very big XML files. The largest one has 67 gigabytes, and it's the history of posts. So 67 gigabyte XML file. That's rather big, rather large. Who think it's big data? That's the correct answer. I don't think it's big data. Because it doesn't fit on in the RAM in this computer, but it fits into my work computer's RAM. So I can just load it into memory and play with that. So it's not big data. So it's quite reasonable. And also, the only data sets that you might be actually interested in might be, for example, the users, which is only about 1.5 gigabyte. And the actual posts have only 41 gigabytes. But altogether, it's about 135 gigabytes of just Stack Overflow data. And if you are interested in some other area that has Stack Exchange forum, you can download that too. They publish everything every 3 months. So now I got the data. So now what? What can I do with it? Well, that happens to me at work quite a lot. Because sometimes I have my colleagues, and they bring me, well, I work with big data. I work with genomic data. So they come up and they give me like a 4 terabytes hard drive and say, OK, here is your data. And I'm like, what do I do with that? And they are, well, the data should tell me, right? Well, the data won't tell you what you are asking. The data don't have any answers by themselves. You have to ask questions. And if you want to go into data science a bit more, remember that the data, the more complex the data are, the more you need to start with questions. And then you can find some answers to that. But without questions, the data won't tell you anything. Big data is not an answer. It's not even a question. So what can we do with the Stack Overflow data? Well, I looked at some of the posts. This is the first ever post on Stack Overflow. It's asking about form opacity. And it has, the best thing is that all the questions and answers on Stack Overflow are tagged with the topic, which for a machine learning person, it's amazing. You directly know what topic each question has. So for example, we can ask, like, what's the most common tag? That's a good question to start with. Well, it's not an interesting question, because that's something that Stack Overflow already tells you if you click on tags. So it tells you that the most common tag is JavaScript. For example, 992 asked today, etc. Second most common is Java, then C#, and then PHP. So that's kind of not that interesting. You could probably guess that yourself. But the interesting thing is that they know when are people asking. So I decided to ask a different question instead. So when are people asking questions? Because then, for example, I can look at, OK, when should I post my question so that I get my answer quickly? And if everyone who uses F# is asleep when I post my question, then I will probably wait quite a long time. So I decided to look at when are people actually asking the questions. So that's my first question. And F# has some really cool things for working with data. And I will be talking a lot about them, and they are called type providers. And because F#, for me, it's something like Python, but with types. It's a statically typed language, which means it gives you typed access to anything, basically. And with type providers, you can get typed access to data. So that's probably quite hard to imagine if you have never seen it before, so I will try to give you some idea. So right now, I have my data in this file. Sorry, this is not my computer, so I'll be a bit clumsy, probably. I didn't want to do that. And I want to move this out of the way. It's not my computer. I can't even deal with this. OK, so here I have my file. And this file has over 1 gigabyte. And I sort of pre-processed the huge XML files into more manageable CSV files. And what I can do now, because CSV file is the default data format for data science. And if I want to now analyze the data, well, some people would open it in Excel, but if you are opening a 1 gigabyte file in Excel, that takes ages. And that's never a good thing. Or you can just try to look at the header, etc. But in F#, what you would do is you create a type. And the file contains information on tags and time, so I will call it the tag time type. And it will be a CSV provider. And it's a type of a type provider that that gives me nice access to the CSV file. So I will now load the actual file. And all I need to do is to do tag time, get sample, which will load the file that I gave it here when I initialized the type. And now if I do tag time dot, here I have some things from the CSV file, like for example headers, but I can also look at rows. And for example, if I want to process every row, all I need to do is to iterate over it. And because F# is a functional language, you use maps and folds and things like that, so I will do seek.map. And I will give it a function for every row, and I will do row dot. And it tells me that the file has 3 columns called day of week, tag, and time. And also, you can probably really see that very well because the tooltips are quite small. But the day of the week has a type system.datetime, which is type for dates and time in .NET. And it recognized that from the CSV file. And you see that it gives me a response very quickly, even though it's a huge file. And it's because it looks at the beginning of the file and it infers all the types of everything that's in the file. And now I know that time, does it work like that in Atom? If I hover my mouse over it, well, it tells me down here that it's date time. We should have made this bigger as well. And the tag is a string. Yeah, and day of a week is a string as well. So if you now try to, I don't know, do day of the week plus a number, then it will give you a type error because that just doesn't work. So this is incredibly helpful if you are trying to deal with some data. And you may have noticed that I didn't even run anything right now. It's doing everything in the background in the editor, in the type system. So this is incredibly helpful. And when I plotted it, I looked at when are people asking questions on Stack Overflow for different tags corresponding to different languages. And this is an example of F#, and it shows me when are people asking questions based on day of the week. So Monday, Tuesday, Wednesday, etc. And quite predictably, it drops over the weekend. So people are mostly using it during the weekdays, or asking questions and answering questions, and then during the weekend, it drops. And this is, for example, how it looks for C#. And the interesting thing is that you can see that the height of the bars changes between the two. Can you see that? So people are asking more F# questions over the weekend than C# questions. So I thought, well, why are people asking questions on languages over the weekend? Well, because, like here, for example, my friend, they are working on their hobby project. So this is my friend who actually wrote the plugin for Atom that I was using to write F# here, Chris. And here he says this tweet, so people often ask me how I find time for all my F# open source stuff. Here's the answer. So he's programming on a holiday somewhere. So maybe he's asking questions on Stack Overflow over the weekend. So just to explain it a bit more, this is my improvised graph. So the number of questions, when are people at work, it will be probably fairly constant over the week because people program at work and are asking questions all the time. And then these are people that are asking questions in the evening, sort of, in their spare time after work, when the family is asleep, or in the morning when they have some time to play with their own stuff. And then we get people asking questions just on the weekend. And that's probably just people who want to play with something, explore something in their own free time. And if people like something and just use it for hobby projects or play with it, then people will be probably asking more questions over the weekend, rather than people who are stuck at work and have to fix some bug by Monday. They will be probably asking some questions, but it will be, well, they will probably be asking questions about the technology more during the weekday. So, and the difference between these two heights will tell me how much hobby a language is. So if the ratio will be larger than 1, it means people are asking more questions over the weekend, and people use it for their own hobby projects and for fun. And if it's smaller than 1, that means people are asking more questions during weekdays, and people are using it for work. And the higher the ratio, the more fun the language is. That's my theory. So this is my proposed weekend index of languages from Stack Overflow. So the most weekend languages, the first most weekend language is Minecraft. It has a ratio of 1.2. That means 20% more people are asking Minecraft questions on Stack Overflow during the weekend, which kind of makes sense. And then it's LWJGL. Has everyone heard of it, about this? It's lightweight Java game library. So people are writing games in their free time. And then SFML, Simple and Fast Multimedia Library, which is also used in writing games to interact with some hardware in your computer and to write graphics. Then D is surprisingly a weekend language, and Pygame, also games. So people in their free time like to do games. That kind of makes sense. Any guesses for the most weekday things? Well, people like JavaScript for fun projects as well, surprisingly. So the most weekday is SQL Server reporting services. Would you play with that in your free time over the weekend? Probably no. So these are the things that people don't ask. You see that on the weekend, 11% of the people compared to weekday ask these questions. So these are probably just some sad guys stuck at work trying to finish something. So then I tried to compare the most common tags. I'm not sure if you can read the labels, but the first one is JavaScript, then Java, C#, PHP, Android, jQuery, Python, and HTML. So actually the most weekend language out of them is Python. Well, it kind of makes sense. And JavaScript is more weekend than C#. And these are, I sort of plotted some things randomly, these are functional languages. So is anyone else doing functional programming? Oh, this is the functional corner. So the first one is F#, then Scala, Clojure, Haskell, Erlang, OCaml, and Elm. Everyone seems to be excited about Elm right now. It's functional programming for the web. It compiles to JavaScript. And it has, well, everyone is excited because it has extremely friendly error messages. So, and to be honest, right now, from Stack Overflow, it seems it's a very fun weekend language because the index is larger than 1. That means more people are asking questions over the weekend. So people want to play with this. And out of these languages, Erlang is actually the most weekday, which kind of makes sense. Also, people wouldn't write some complex distributed systems over the weekend. And then Scala is the most enterprisey stuff. And after that is F#, and then Clojure and OCaml. And the second most weekend language is Haskell. So people use Haskell mostly for fun projects and in their free time rather than for work. Does it correlate with your intuition? Well, I will put this, when I get a bit of free time, I will put this on the web so you can look up your own favorite languages and compare them. So then I also looked at some very related things. For example, for continuous integration, there is one language, there was even a question on Stack Overflow asking, so would you use Jenkins or Travis for an open source project? It was closed because it's not a proper question. It's asking for an opinion. But I can answer that. Would I use it for an open source project or not? Well, because people do quite a lot of open source in their free time. So let's look at this. So Travis CI has much larger index than Jenkins, which means for open source projects or some fun projects, probably use Travis for continuous integration. And also the reason is, if you think about it, that Travis gives out free hosting for open source projects directly from GitHub. So it's much easier to use that rather than Jenkins, which you have to host yourself. So it also kind of makes sense. So they have very similar icons, actually. So when you are designing product, it's probably a good idea to think about if you want your audience or your users to use it in their free time as well or not. And if yes, then make it as easy as possible for them. So what can we do next? Some other questions. Well, I was looking at some profiles on Stack Overflow, and I realized they also give you where the people live. They give you a location. So I thought, okay, nice. I can find out, for example, what are people programming in India. I can do that. So my next question was, where are people when they are programming or when they are asking questions? And the data are quite nice, quite promising, because over 5 million users are registered on Stack Overflow in total, and 770,000 of them filled in their location. That's quite a lot of people. That's almost 15% of the whole user base. So I can use this. Like even, well, when people are predicting results of elections, they never have such a large sample as 15%. So I can use 15% to estimate where are people that are programming. So some of the locations look a bit simplistic, like $home. Some people actually have that as their home location on Stack Overflow, so that's probably not very helpful. But when I examined the data directly, I found that 83% of the locations listed on Stack Overflow directly correspond to a country in the world. Nice. So I got information directly for 83% of the people. Well, some people give you the address, like not very specifically, like this example. This is a user in location on Stack Overflow, so unfortunately Germany, well, it's still Germany. And some people give you the address very, very specifically, up to their office number. Maybe they're expecting that someone will come and knock on their door and say, thank you for the answer, it really helped me. Or maybe they expect someone to come, oh, why are you asking that question? So, but some people give their full address up to their house number, but I don't think anyone is going there to ask them. I had to look this place up, and it's this place. I'm not sure if that person actually lives there, but yeah, it's nice to see that people are probably asking Stack Overflow questions from everywhere. So next time that person asks a question, just go there and tell him something directly. So where are the people? Well, I could locate about 83% of the people, but it still left me something like 120,000 locations that I couldn't locate directly. So that would be a shame to just throw this data away, because some of the locations were, for example, Pune or Mumbai, and it's pretty clear where they are, but it's not a country. So I decided to use type providers again. There are quite a lot of location services that you can use online. I decided to use Bing search because they give you 250,000 requests for free. So I got about 2 attempts to do this right. Well, with F# I need only 1 because it's so simple. So it's a REST-based service where you give it some string with location, and it will give you back GPS coordinates and country name and the precise location. So let's do this, and I will show you how to use it from F# with type providers. And now you might be asking, why do I need type providers? Well, it's a REST service, and it returns a JSON document. So normally you would probably write some wrapper around the service and call that, and then parse the JSON in some way. Well, I don't have to do that. I have type providers. So here I have an example request for the Bing search. And it contains my key, and it gives me something like 5 results, etc. It's quite a long string, so let's skip that. And all I need to do is take this example request and create a type out of that. So I'll call it Bing search. And this one will be a JSON provider, because I will get a JSON document from Bing. And I will give it my sample request. And that's basically all I need. What doesn't it like? JSON provider. Oh, yeah, missing D. OK. And that's basically all I need. Because now I can write a function that will actually call the REST service and get me some location that I'm interested in. So I will call the function locate, and I will get some location X. It's probably not a very good naming convention, but X marks the spot on a map, so I'm using that. So all I need to do is call Bing search. And now give it the actual request. Oh, I'm completely lost. I'm normally on a Mac, so I don't remember any Windows keyboard shortcuts, etc. So now it contains Prague as the example location, because I'm from Prague. So let's give it X instead. And that's basically everything. So now I will get the result into something. So this will be the response. And now, if I do response dot, it gives me all the things that are in the JSON that I got back from the REST service. So it contains some authentication result, copyright, etc. And if I remember correctly, the actual information are in element called resource sets. So I will parse that. So I'll scroll up so that you can see better. So the resource, and again, I can do resource dot, and it tells me everything that's there in the JSON document. And it's quite an ugly and nested and huge JSON document, but the information that I want are in resources. So I can do another array.map. So, and now, if I do r dot, these are all the information that are in the JSON document that I'm actually interested in. So I can go into address, and in address, I'm interested in the country to get the country where people are. So that's all I need. And I don't have any wrapper around this JSON service. All I did was give it an example request with a response, and that's it. It's basically got together the whole structure of the JSON and everything. And I have typed access to it as well. I'll just change this so that I collect the results properly. And the locate function, well, if you saw it down here, it tells me that it's taking a string and it returns an array of strings. So that's exactly what I want. It's a typed language, so it gives me everything I want. So for the first time today, I will actually run something. So let's run this, and let's test this. Oh, yeah. I need to run everything. And what I have here on my right side is F# interactive. Like if you are using, for example, Python, you get Python console or IPython console. This is the same thing. You basically send code to it, and it evaluates everything. It's a REPL. So now I have my function to locate a place in the world. So let's check this. So let's locate Pune. And what it returned here, okay, so here bottom is the answer. Pune is in India. Yes. So I can ask anything. I can ask, for example, where is Cambridge, because I live in Cambridge. And Cambridge, according to Bing search, is most likely in the US. And that's because there is another Cambridge in the US, which has MIT and Harvard and all these universities. But I am from a different Cambridge, so I will give it a Cambridge, UK. And now the most likely location is United Kingdom. So it's fairly reasonable. And I was playing with some random stuff that was on StackOverflow. So if people put in that they are the citizens of the universe, let's see what it does. And the universe is in India. So that's very good to know if you are ever looking for the universe. So with this, I managed to locate the rest of the users that put in some location, or at least approximately. So I tried to plot it, for example, for JavaScript, and it's kind of not very interesting, because you can probably expect that there will be quite a lot of JavaScript programmers in the US and in India, because there are many programmers in general. So it's giving me sort of an answer, but it's kind of an obvious one. So in India, actually, there are about 26,500 registered users on StackOverflow that are asking and answering JavaScript questions, in case you ever wondered. But so this is not very interesting. So I decided to go more mathematics. So what I'm interested in is if I come to an event like this, who am I likely to find? Like, for example, where do I find F# programmers? Where am I more likely to see F# programmers? So I decided to normalize the numbers that I'm getting from StackOverflow. So I'm looking at, for example, n here. Oh, this is not very important to understand this directly, but n is the number of users from StackOverflow that are asking and answering questions about specific technology that I managed to locate. So this will be fairly small usually. And I can actually recalculate it based on the number of people that live in a country, which will give me a probability of having a programmer of a specific category in specific country, and then normalize that based on how many users I managed to even locate and how many registered in total. And then I multiply it by 1 million to get a very, very scientific measure. The unit of this is ppm, programmers per million. It gives very strange numbers for very small populations, but I hope it's fairly reasonable for larger populations. So to calculate this, to find out where people really are, I also need to get the population of each country. And I think I mentioned type providers about 2 times today. I'll mention it again. I can use type providers to do that. Because where do you find this kind of information? Well, Wikipedia, probably. And you would have to parse some table from Wikipedia to get population of every country, and that's quite a lot of work. But type providers come to the rescue again. So here I have the example from Wikipedia, and it's from an article called List of Countries and Dependencies by Population. Here is the name. You can go there and change it right now, but I'm using a stable ID of one specific edit, so it won't change anything in my demo. So you have seen the pattern, right? So you can probably guess what I'm going to do now. Well, I will do type, called, let's say, Wikipedia or Wiki, and I will give it the URL. And it will be an HTML provider because I'm interested in HTML data. And now I will actually load the Wikipedia table. Get sample. And now, if I do wiki dot, it tells me that on the website there is some HTML code that it's parsed within this type provider, and there are some lists and there are some tables. And I'm interested in the tables. So, And if I now do t dot, it tells me that there is a table called countries and dependencies by population, which is exactly the thing I want. I don't have to parse anything. I don't even have to look at the URL. It's always here. And now this is a table, so I can look at the headers, I can look at the HTML that's encoding the table, and I can look at the rows. And if I look at the rows, now I can do, let's say, map, fun row. Yeah, F# has a fun as a keyword. So row, and the columns in the row tell me the percent of world population, the country name, the date when it was measured, and the population and the rank, etc. So I, again, don't have to look at the table at all. So I will look at the percent of world population. And I think this might be an array. So let's actually run this. So now here I have just the percent of world population. I might want to know the name of the country as well. So I will do row country. And let's run this again. And here, India is the second, and it contains 17.5% of the world population. So I parsed quite a large data table from Wikipedia without even looking at the table at all, because it all tells me here in the type system what's there. So this, you can probably see how useful this is if you want to get some data quickly into your editor. So I did that. And so where are people really? So this is an example of F#, the relative frequency of F# programmers among StackOverflow users. And you can see that if you want to do F#, you should probably move to Scandinavia or the UK. In India, there are not that many F# programmers, actually. There are only about 0.3 F# programmers per million people. So you should try harder, guys. And I also have the code to do this here. I will try to load this, and then we can look at some other languages as well. All right. Now it's loading everything, and it's quite a lot of languages, so it might take a couple of seconds. Okay, everything is loaded. So my other language that I use on a daily basis is R. So this is the frequency of R users in the world. So if it's low, it's green. If it's high, it's red. So again, Scandinavia and the UK, and China uses R a lot, and Australia. Quite interesting. So let's look at JavaScript. And JavaScript is the highest density of JavaScript programmers is actually in China and in Iceland. Wow, who could have guessed? In India, based on my very approximate estimations, there is supposed to be about 141 JavaScript programmers per million inhabitants. That's a lot. So, are you interested in any other language? That's a lot of voices. Let's look at Java first. And Java, that's interesting. The highest density is in China again, and Ireland. Ireland is a Java country. And I will look at Python as well. It's a data science language. So, so in India, there are about 38 Python programmers per million inhabitants. That's still a lot. Well, it also should print out some more information. No, that's okay. Okay, so if you want to ask, well, sometimes I got a bit suspicious if it's actually working, so I decided to ask about some questions that are, some languages that are quite regional. So I look at Erlang, for example, because that was invented in Sweden, and they are using it there quite a lot. And the moment of truth, Sweden and China. I think the results for China are a bit skewed, probably. But the highest one comes in Sweden, which is the country of Erlang. So that's good, at least. So, and I was also looking at some outliers that show like more programmers of each technology than I would expect for some population. And the main outlier was actually the Dominican Republic. And I guess these are all the digital nomads who just go through Dominican Republic to code somewhere on a beach. And that's an outlier for most of the languages. Or maybe there is just a group, a very small group of programmers that do everything and answer all the questions. Well, first of all, treat these results as very approximate. Because, as you probably know, all the election predictions, for example, are usually very skewed. And yeah, they never predict what actually happens. So this assumes that in every country there is roughly the same ratio of people who actually register on Stack Overflow and give me their correct location, which will be probably higher in some countries and lower in other countries. But I don't have enough data to estimate this properly. So there is a huge sampling bias in this. So let's be careful about it. But still, it tells you something about which languages are used in which country. So I looked at tags and I looked at users, sort of. I looked at their locations. But the cool thing is that if I put these together, like the groups of users who use certain languages, who answer and ask questions, this sort of gives me communities. Because people who use, for example, I don't know, F# and are also doing some C#, there's probably quite a high probability in there. But for people who, well, I looked at overlaps between communities and people who are using R and at the same time doing iOS programming, that's a very low probability that they will be the same people. So people are using similar languages, then they come from same community. So tags sort of define relations between people. And to give you some examples, so this is me and my friend Chris, who again wrote the plugin that I was using called Ionite. So we both use F#, so that makes us similar. I don't use any C# and he does use C#, so that makes us different. And then, yeah, we both do some JavaScript. I use R, he doesn't, and none of us uses COBOL. So this sort of defines how similar we are as users. And if I look at columns in this, this tells me how similar are languages based on users who use them. And also this gives me a matrix representation of the Stack Overflow data. And whenever I have a matrix, I'm a happy data scientist. And you should be too. So what this gives me, well, overall, there are more than 5 million users on Stack Overflow and over 44,000 tags. That's quite a lot of data. And dealing with matrices that are this large and very, very sparse, they have a lot of zeros, it's quite hard. So I decided to look at just a small subset of the data, and I looked at users that have more than 1,000 posts. I think Thomas here, who will speaking after me, has that. And tags that have more than 5,000 posts. That means questions and answers with that specific tag. So only established technologies. So this gave me 800 tags and 1,600 users who use Stack Overflow a lot. So this should give me some kind of idea about how different technologies relate to each other. So I got the data in a matrix, and I was thinking, so what can I do with it? Well, as a proper data scientist, I visualize everything. Because if you don't visualize data, they will fool you much more often. So I decided to use a method called tsne, the T-distributed stochastic neighborhood embedding. That's quite a mouthful. So I will try to give you some idea how this works, because this is an extremely useful method to visualize very high dimensional data. But don't worry about the mathematical details. So the key word here is embedding. So what this method does, it takes the very high dimensional space and it tries to embed it in 2D, in 2 dimensions, so that you can look at the data. So we'll be embedding the, I think, 1,600 dimensional user space and the 800 dimensional tag space into 2 dimensions. So it must be very simplifying. But what it's trying to do, imagine a high dimensional space. Imagine 1,600 dimensional space. That's a bit difficult. So instead, imagine a 3D space and imagine a sheet of paper in the 3D space. And it's sort of making it into a 2-dimensional manifold where the data are concentrated. And the data are usually concentrated on some lower dimensional part of the space. So you have the paper, and there are points on the paper. And if you look at them, these 2 are very close in the 3-dimensional space. But actually, in the logic of the data, they are very far from each other. So I don't want to just look at points that are close to each other in the high-dimensional space and project it or embed it in the visualization. I want to look at it overall. So what t-SNE does, it looks at just local neighborhood of each point. And it tries to preserve the thing that if 2 things are close in the original space, they will be close in the embedding as well. And if they are far from each other in the original space, then they can be anywhere in the embedding. So it just tries to put things that are similar, very close to each other in the visualization. So let's go to how to actually deal with this kind of method. It's very mathematical, because you have to just define some like probabilistic space where you project things into the embedding. Well, what you would do in practice, you just call a function. In R, you just open a library called t-SNE and called function called t-SNE. Easy. Well, in F#, you can use type providers, because you can call R using type providers from F#. I won't be showing it to you directly here because it takes some time to compute, but hopefully you can see it. All I'm doing here is I'm opening R provider and then doing R dot, and in the same way I got typed access to anything in the data set, I can get access to anything I have in R, all the functions I have there. So I can do R dot t-SNE and call it in much the same way that I would do it in R. So I can pre-process my data in F# and then just call R to do the mathematical stuff and then get data back into F#. So I did that. I called t-SNE from R, and I used R function for plotting, and this is what I got. Nice, right? The thing is, well, the best thing about R is that it was written by statisticians. The worst thing about R is that it was written by statisticians. And it's true. If you have ever used R, it's, well, it's not a proper programming language. And especially for some visualizations, you can't do that much there. So I decided to use F#, not type providers in this case. I decided to go for JavaScript, but because I'm an F# person, I decided to go for Fable, which is an F# to JavaScript compiler. And Thomas will be showing you much more from Fable. So from Fable, I can actually optimize, because it's JavaScript, I can do anything. I can actually optimize the position of labels for each point. So I can get something that's actually explorable compared to the R thing. So if you can see the labels, for example, this is a little cluster of people that are doing Android. And it has everything from like Android layout to Android widgets, etc. So these are just people doing Android. And it realized that all these tags are related because it's the same people using them. And this is another cluster of people doing JavaScript, for example. And for Google Maps, for some reason. Are people who do JavaScript more likely to use Google Maps? Probably. And for example, here is JavaScript, Angular. Here is Angular again. So it realized that these technologies are related. And this is another cluster of people that are confused with object-oriented programming. So constructors, inheritance, polymorphisms, etc. So these are very related concepts. But again, the algorithm didn't know anything about it. It just looked at users who are asking or answering questions. And I have another form of the visualization running somewhere. Okay. So here I can actually locate different tags. So if I look at F#, F# is here, yay. So this is F#. You can't again see the tooltips, they are very small, so sorry for that. But next to F#, there is one with mono. And normally I'm using F# on a Mac using mono. So it means that the F# community is very, very like, more centered around like, cross-platform development. And if I look at C#, which is another .NET language, it's here. So that's quite far from F#. And next to C# is .NET in general. So that's kind of nice. So I can explore this interactively as well. I wouldn't be able to do this in R. So this is very useful even in my work, because this is an example from a bioinformatics research where they were looking at at which locations in genome are people different. And they were visualizing those. And they get some information, I think, mostly from the US. So this is actually a cluster of Chinese people, and it's roughly separated in the middle. And it projected like their genomic locations where they are different, which are like millions of locations, into 2D. And these are slightly two different communities when one of them is US Chinese and the other one is Chinese from China. And these ones are Indians, actually, living in, living in the US. And these are the Chinese people, these are Japanese. So it's sort of projecting genomic similarity into 2D, and you can see which communities are more related to each other than others. So it's a very useful method of visualization of very high dimensional data. So let's move on. I looked at tags, I looked at users, I looked at some technologies, but I didn't look at questions and answers at all yet. So we will do that very quickly. So I decided to play with something called word2vec, which is a fun deep learning method. And it's a word embedding. And you have heard the word embedding today once before for t-SNE, which was an embedding of high-dimensional space into low-dimensional space. Well, word2vec is an embedding of words into numbers. That sounds very weird, right? So this was the 2D embedding, and now we'll do just something slightly different. And before, we were looking at points and their local neighborhood, which was defining like a neighborhood of a point, which we used for the embedding. But now, what t-SNE does, it looks at a word and its local context, the words that are used around it, and creates an embedding from that into a numerical space. So, as an example, so F# is a functional language on the .NET platform, and a Scala is functional object-oriented language on the JVM. So from this, you can see that F# and Scala are sort of surrounded by similar words. So they should be projected into the similar subspace. And they are both languages. And the platform and JVM, it's also in a similar place in the sentence. So if you do some deep learning magic and stuck this into a neural network and encode it as numbers, you will get a numeric representation of words. Now this sounds very abstract. But what you can do with it afterwards is you can do arithmetics with words, which is a lot of fun. Because first thing I did, well, for example, what do I do if I use Scala and subtract JVM and add .NET? What do I get out of this? You think F#. Well, Scala is a bit more object-oriented than F#, actually. So what I get is the first two hits were C#, and after that F#. So these are the equivalents based on how people use these words in sentences. So what do I get if I subtract .NET from F#? C#? No, C# is .NET. What do I get? Well, I get SML, which is a standard ML, and because F# is an ML-style language, it was created using the ML syntax. So, and OCaml is another ML language, and then I get Haskell and Idris. And these are other functional languages. So it realized from how people use words like F# and SML and OCaml in Stack Overflow questions and answers that these things are related. But SML and OCaml are never used together with .NET. So if you subtract it, you get these things. So play with word embeddings. It's a lot of fun, actually. And again, it's quite useful even in my research, because that's what we want to do. Well, here I have some academic papers, like evaluating word representations in biomedical entity named recognition tasks, applying word2vec to medical documents, and doing word embeddings for biomedical papers. Because it would be great if I just have some kind of, let's say, a lung cancer, and this gene is important there. And based on literature, what's the equivalent of this gene in breast cancer? And it would give me an answer. Well, we are not there yet, but it's work in progress. And I think this is very exciting. But now the ultimate question. Is Stack Overflow and actually a meritocracy? If you go onto Stack Overflow and you answer a question, will you get score based on the quality of your answer? Or will you get a score based on, like, people see a famous name and they just click upvote? So, any experience? Well, we can use the mathematics to actually look at this, to prove this, if it's really the case or not. Well, this is what happens if I plot against each other author reputation on the x-axis and the score that they get on Stack Overflow on the y-axis. This is a very ugly plot. So I can put both of these axes into logarithmic scale, and it already tells me that, for example, if my reputation is around 100, then I probably won't get more than 10 for my answer. Which, well, that's interesting, because the higher the author reputation, the higher the score they would get in general. But that might be just because they answer a lot of questions and they answer more interesting questions. So I did some regression. And if you don't do any machine learning, regression is just a way to predict a number from your data. So given some input data, I can try to predict the score you will get on Stack Overflow. Well, and the input data are huge. So I try to put in a lot of different factors that might be predictive of what score you get. Like if your answer was accepted, how popular was the question, what was the number of tags, if it's like a very general question or a very specific question, how many people tried to answer the question, how many comments did your question get, etc. And then I try to predict the score. And I tried a lot of different machine learning methods. The interesting thing is that you can predict only about 60% of your score. So it's quite unpredictable. And the most predictive factors, if you are answering question on Stack Overflow, are actually how many people favorited the question, how many people looked at the question, and if your answer was accepted. So that's kind of nice, because it tells you that if the question is popular and it's interesting, and you answer the correct answer, and you are the fastest, then it's good. So Chuck Norris approves. Because that means that if you are fast and you answer interesting questions, then you get a good score on Stack Overflow. But then I looked at some plots that show me how well my models fit the data. And I looked at them, and it's not that important what this actually shows like properly. But on the y-axis, you have how much my prediction is different from the actual data. And on the x-axis is something called leverage. And leverage, in general, it's like something that you use to shift a lot of weight. So leverage in statistics means some points that have big weight on your prediction. So this is an example from statistics. So this one point in the corner, based on where it is, it will move my whole prediction because it's an outlier. And it has a lot of leverage. So there is some outlier that's shifting my whole system completely. So you can see that there is this group of data here that's way out of range for the rest of the data. And it's affecting my prediction. So I was thinking, oh, so what's that? That's really strange. Whenever you get something, it's weird. You have to investigate. So I looked at those points, and I found that they are all from John Skeet. And if you have ever done any C#, he's basically the Chuck Norris of C# on Stack Overflow. So he answers all the questions. He has the highest score on Stack Overflow out of all the users by far. So my conclusion is that if you are answering questions on Stack Overflow, the quality of your answer matters, unless you are John Skeet. So I guess, well, John Skeet is not here. So for you guys, quality matters. So answer good questions and answer them well. So I want to conclude. I think I've been talking for an hour. So on the technological side of things, I was showing you quite a lot of type providers. And type providers are amazing for working with data because you don't have to write any parsers. Usually you don't have to look at the file at all. You just get everything directly in your editor in the type system. And that's great. But in the end, I was using some R in this. I was using some JavaScript as well. And the great thing is you can use whatever you want. When you are playing with data that are interesting for you, just use whatever works and have fun. Because on the data science side of things, here I was playing with the Stack Overflow dataset because I understand the domain, sort of. And I used to play with Star Wars data because I also understand the domain. So find some dataset that's interesting for you and play with that if you want to get into more machine learning or data science stuff. And there are a lot of data online, so just pick something and play with it and use whatever works for you. And if you want a break, maybe move to Dominican Republic because that's where everyone is. Thank you.